Hi children, good morning. Welcome back to our session. What is the topic going on for us? It is the electric current and its effects. Is it? Yes. So in the last class we have learned about the magnetic effects of the electric current. Have you watched the videos, children? Very good. So today's our topic is about electromagnet. Magnet. We used to play with the magnet. But here electromagnet. Without using the magnets, by using of the electricity, we can create the magnets. Let me see how. An electromagnet is a type of a magnet in which the magnetic field is produced by an electric current. So here we are not using the magnet, but which we are going to produce the magnetic field. Magnetic field is produced in an electric current. The magnetic field disappears when the current is turned off. When the power is there, it is going to attract the iron things. If the power is not there, it is going to lose its magnetic power. Electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Who invented this? The first time, William Surgeon. William Surgeon. You can see the picture of him, William Surgeon. So, how to know about this? Let me conduct a small activity, children. For this activity, we need a copper wire, a small battery or a cell. Also 9-volt cell is also it's enough. Then open and closed key. Then a simple iron nail. Then first take a simple iron nail, children. For this nail, wound the copper wire. So you have to wound the copper wire for this nail. Okay. So I have wounded the copper wire for the nail. Then two ends of the wire is there. One end of the wire you can give the connection for the cell for the positive, and another end of the wire you can give for the negative. And we can arrange the key also, children, here. So that is the switch. If the switch is open, then arrange the small pins here. Pins means don't go for the heavy one, because here we have taken only the small things. So for that our cloth which we are going to use, the safety pins or the stapler pins are there, no? Just keep it under that. Now if you on that switch, what will happen here? The magnetic field will be produced. How can we know? These pins will get attracted for this iron nail. If the current is on, then switch off. Then what will happen? All the pins will be dropped out. Is it? Yes. So this is one of the small activity to know about the electromagnet. An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. This is one of the small activity. And where we use this, children? Always we are telling the electromagnet. Then where we are going to use this one? In the cranes, to lift up the objects. So some of the electric cranes, the heavy loads of the iron things like machines, which we cannot be lifted by the normal cranes. Then at the time, if you use these electromagnets, easily it will be attracted towards that magnet and we can lift it from one place to the another place. Then we are going to use in some of the toys and some of electric gadgets. This electromagnets are going to use it. So this is about our electromagnet. Okay. So copy down this definition and I will show you a small video regarding this electromagnets. Watch the video. If any doubts are there, you can clarify. Okay, children? Thank you. In the next class, let me meet with the new topic. Okay? Thank you and watch the video. Okay? Bye. Thank you, children.
Electromagnets. In this module, you will learn about electromagnets. You might have seen a crane lifting heavy loads of scrap iron. But how does a crane lift heavy loads? A crane has a strong electromagnet attached at its end. This electromagnet attracts all magnetic materials in scrap. You are introduced here to the term electromagnet. To find out what an electromagnet is, let us do a simple activity. For the activity, you need an electric cell, an iron nail, a piece of insulated copper wire, and some paper clips. Let us now start with the activity. Wrap the insulated copper wire tightly around the iron nail and attach its bare ends to the terminals of the battery. What do you observe? A current flows through the wire and the iron nail turns into a magnet. Now, remove the connection. This will stop the flow of current through the wire and the nail will demagnetize. So, the iron nail behaves as a magnet as long as current flows through the circuit. Such a magnet is called an electromagnet. An electromagnet consists of a coil made from several turns of insulated copper wire wound on a magnetic material like iron. An electromagnet can be switched on and off and thus is also called a controlled magnet. Let us again consider the initial setup. Connect the iron nail wound with the insulated copper wire to two cells instead of one. You will observe that more paper clips are attracted towards the electromagnet. Thus, the strength of the electromagnet increases on increasing the strength of the current. Now, increase the number of turns of the coil on the iron nail. This makes more paper clips attract towards the electromagnet. Thus, you can conclude that the strength of an electromagnet increases with an increase in the number of turns of coil. Thus, the strength of the electromagnet increases on passing a larger current through the coil and on increasing the number of turns of the coil. Now, bring a bar magnet near the current-carrying coil or the electromagnet. You will observe that one end of the electromagnet repels the north pole of the magnet, whereas attracts the south pole of the magnet. What do you infer from this observation? This end is the north pole of the electromagnet. Remember, like poles repel and unlike poles attract. The other end of the nail is attracted towards the north pole of the bar magnet. This implies that this end is the south pole of the electromagnet. Thus, like permanent magnets, electromagnets also have two poles, north and south. On changing the direction of current in the coil, the poles of an electromagnet get reversed. Can you think of some devices of day-to-day use that use electromagnets? Well, electric motors, generators, electric bells, audio cassettes, speakers, and telephones are some devices that use electromagnets. In this module you have learned An electromagnet consists of a coil made from several turns of insulated copper wire wound on a magnetic material like iron. An electromagnet is a kind of temporary magnet. It behaves as a magnet as long as current flows through the coil. The strength of an electromagnet can be increased by increasing the current or the number of turns of coil. Like permanent magnets, electromagnets also have two poles, north and south. Some devices that use electromagnets are electric motors, generators, electric bells, audio cassettes, speakers, and telephones.